All right, today we're going to look at section 8.5, part A, adding and subtracting rational expressions. Back in elementary school and middle school, you learned how to add fractions. We'll use the same principles in Algebra 2, but apply them to fractions involving polynomials. So when you already have common denominators, you can simply add and subtract the numerators, but leave the denominator the same. For example, if we had a basic numerical fraction 2/7, we were adding another numerical fraction 3/7, because we have a common denominator, we can keep that as a 7, and we simply add the numerators. So our solution would be 5/7. In an algebraic fraction, the same thing applies. If our denominators are the same, in this case they're both x plus 5s, we would keep that denominator. Okay? And then we simply add or subtract, in this case we're adding, the numerator. So we would combine like terms. We have an x plus 2 more x's, so we get 3x. For the constants, we have a -1 and a +2, so we end up with a +1. Okay? Sometimes when you add or subtract, your answer can be reduced. For example, in this one, if we have 7/10, we're subtracting 2/10, we're left with 5/10. But that can be reduced. We can divide out a common factor of 5 to get 1/2. Same thing is true with algebraic ones. Now, with subtraction, you have to be very careful because you're subtracting everything in that second fraction. Our denominators are the same. We have an x plus 2, so we're going to keep that x plus 2. We're going to look at the numerators. We have a 2x plus 5. We're subtracting a 1, so we end up with 2x plus 4. But on this one, we can reduce that a little bit. We can factor a 2 out. We're left with x plus 2 as our second factor in the numerator. And then we can reduce out those x plus 2's. But remember from yesterday, we had to list restrictions. So let's go ahead and jot down on this one. We know that x cannot be a -2 because it would create a 0 in the denominator. We then can reduce, and we end up with a final answer of just 2. All right. In our next set, it says when the denominators aren't the same, we have to find a common denominator. So I want you to highlight that. Because that's a critical step. All right. When they have nothing in common, we're going to multiply each fraction, both the numerator and the denominator, by the other denominator. So looking at this one, we have a 5 and a 4. They don't have any common factors between them, so our least common denominator would have to be a 20. All right, now we want to create a denominator of 20 for both of those. To get a 20 in this first fraction, we would have to multiply by a 4. And whatever we do to the denominator, we have to do to the numerator. In the second fraction, to get a 20, we'd have to multiply by 5. And again, whatever we do to the denominator, we have to do to the numerator. So we simplify this. We've got 4 times 2 would be 8. We have 1 times 5 is 5. And now we have a common denominator of 20. So simplifying, we get 13/20. Okay? The same thing is going to be true here. We have 2 separate factors. One's an x plus 7. And one's an x plus 3. Our common denominator has to include both of those factors. So we need an x plus 7 and an x plus 3. All right, that's what we want in our denominator. Now to get that, we have to multiply this first fraction by the x plus 3. Again, same thing on top and bottom. And we have to multiply the second fraction by the x plus 7. All right, so for this first piece, we have a 2, it's being multiplied to x plus 3. That simplifies to be 2x plus 6. Then we are adding our second piece. In the second part, we distribute our x, we get x squared plus 7x. And then we simply combine like terms. So this numerator becomes x squared plus 9x plus 6. all divided by an x plus 7 and an x plus 3. All right. Again, if you're asked for restrictions, we would say that x cannot be negative 7 or negative 3 because it creates a 0 in the denominator. When the denominators aren't the same, but they have a common piece or a common factor, we're going to multiply the top and bottom of the fraction only by the piece of the denominator that is missing. So if you look at this, our denominators are 7 and 14. Our LCD would be a 14. We can make that 7 become a 14 to match the other fraction, simply by multiplying by 2. So here's a case where one of the denominators is already fine the way it is. This now becomes 2 times 3 or 6 plus 5 all over that common 14. Reduces to 11/14. Okay? Now, in an algebraic fraction, make sure that you factor everything so you can see what the pieces are. This x squared minus 4 is really an x plus 2 and an x minus 2. So to create a common denominator, we need both an x plus 2 and an x minus 2. And so my first fraction is fine the way it is, but my second fraction is missing only part of it. It's missing the x minus 2. So we would have to multiply that in. So now we have a denominator that has an x plus 2 and an x minus 2. Our numerator is all of this. So if we simplify, we have an x. We're adding to it 1 times an x minus 2, which just gets us x minus 2. Simplifying that, we would have 2x minus 2 all over x plus 2 and x minus 2. We could factor the numerator, and you should, because if there are any common factors that we can reduce out, we would want to do that. So we could factor a 2 out. We're left with x minus 1. However, that doesn't match any of my denominator factors, so I really can't reduce it any more than that. And we can just leave it in its factored form like that. Again, if we had to list restrictions, we'd say x cannot be a positive or negative 2. Those would make the denominator 0. All right, so a couple more examples. We do not have common denominators, so let's go through and think of it in its factored form. The x minus 2 is factored as far as we can go, but the x squared minus 3x plus 2 could be factored into x minus 2 and x minus 1. So looking for our LCD, our common denominator, we need to have an x minus 2 factor, and we need to have an x minus 1 factor. So we want to create that. And to do that, our first fraction has the x minus 2, but it's missing the x minus 1. So we're going to have to multiply that in. Okay? Now, for this particular question, we have an x minus 1 that has to get multiplied to an x plus 3. We're going to have to FOIL that out. And notice that we are subtracting this whole piece, this whole 6x minus 7. And that's a place where a lot of mistakes typically happen with that subtraction step. All right, let's clean this up. If we FOIL the red part, we get x squared. Outside is 3x, inside is negative 1x, which leaves us 2x. And our last term is negative 1 times 3, or negative 3. We're then subtracting a 6x, and we're subtracting a negative 7, which means we're really adding a 7. Our denominator we're going to keep still in this factored form, and then we're going to combine any like terms in the numerator. So my final here would be x squared. A 2x minus a 6x would be negative 4x. A negative 3 plus a 7 would give us a positive 4. Over our common denominator. All right, now, for this particular question, we actually can take it a little bit further. because x squared minus 4x plus 4, this piece could be factored into x minus 2 times x minus 2. And in doing that, you can see that we are able to do some reducing here. I am still going to list restrictions. X cannot equal a 2 or a 1 because it would create a 0 in our denominator. We can reduce out one of our x minus 2's from the numerator and denominator. So my final reduced answer is just x minus 2 divided by x minus 1. All right, let's look at our last one here. We're looking at an addition problem. Our first fraction has a denominator of x minus 1. Our second has the same denominator as our previous example, and we factored this into x minus 1 and x minus 2. So my first fraction here is missing only a piece of it, the x minus 2. All right, cleaning this up, our denominator now is going to be an x minus 2 and an x minus 1. Our numerator is going to turn into x squared minus 2x if I distribute that x. We are adding to it a 2x minus 1. And when we combine like terms, we end up with x squared minus 1 for a numerator. And once again, we can factor that further. X squared minus 1 would factor into x plus 1 and x minus 1. We're going to list our restrictions and say that x cannot equal a 2 or a 1. And now we can reduce out an x minus 1 piece. So my final reduced fraction here is x plus 1 divided by x minus 2, with the restriction that x cannot be 2 or 1. All right, so you are going to work on section 8.5a. It is a Delta Math assignment.